Oops. Okay. Good afternoon, everyone. Thank you for joining us at this. This is our second scaffold design webinar, and last week we started with the first one. Before I begin, let me just maybe introduce the webinar instructors for today. So today we have myself, Maya Sari Lim. I'm the president and CEO of SE3D, and I have with me also Oliver Lai. Oliver is a biochemical engineer at SE3D. He's also our curriculum development specialist if you have any questions about curriculum, whether it's for high school or universities. So with that, I'll go ahead and kind of start off with recapping what we did last time. So in the last webinar, we did the kind of a really basic scaffold design, and really we're using very simple tools such as Tinkercad and the Slicer program to kind of walk you through how to create a 3D model, and then using Slicer to kind of design the different infill patterns that you might want to customize in the scaffold that you want to print. And also, something as simple as creating like a cylinder. How do you adjust the thickness of the cylinder and whatnot? And that was basically what we did in the last webinar. And we also did the prints using a very simple material called Pluronic, which we'll show you shortly as well. If you have any questions during the webinar, please type in the questions in the chat box. And what I'll do at the end of the presentation is that we'll address some of these questions, and definitely at the end of the demonstration with the walkthrough that Oliver will be kind of walking you through the process, you could also ask questions at the end as well. All right, so let me first start off with kind of going over the process of bioprinting or 3D printing. And basically here, these are the simple 3 steps that we will be doing, which is one, designing a scaffold using tools like Tinkercad or any kind of 3D CAD design software. And then in the next step, you will actually take that 3D model and slice it using a slicer program. And in this case, we're using the program called Slicer. And finally, you will then take the G-code files, that is the output from the slicer program, onto the printer control program. In this case, we're using an open source 3D printer control software called Pronterface. And that's how the bioprinter is able to sort of take in the information that, that you've already provided to print the scaffold that you have designed. So I also want to quickly introduce, I guess, the printer that we'll be using today, which is our new Rebel Mini bioprinter. This is really one of the most compact bioprinter that you'll see out there in the market. And you'll see shortly as we turn into the video that it's a very small, lightweight, really easy and versatile tool. Also one of the most affordable tool, and we highly recommend for beginners who are new to this space. I think this is a great tool that you find really easy to use. And we also design it so that it utilizes swappable, disposable syringes and also disposable needle tips. So in this case, we could actually fit both a 5 ml or a 10 ml syringe. The bioprinter that the Rebel Mini is a very simple extrusion-based bioprinter. And the material that we'll be using today is a synthetic hydrogel called Pluronic, and is basically composed of these 2 polymers. And one of the key properties about Pluronic is that it's non-toxic, it's biocompatible, and typically people use this as sort of a sacrificial material because it has a thermoreversible properties that allows you to sort of melt the material away, so you can easily create channels within other types of gel systems. So this is one of the really common biomaterials that is being used in the bioprinting space. And today's activity, we'll basically walk you through 3 different steps or 3 different concepts. The first one is, defining your print resolution. And in this demonstration, we'll basically, go from a thicker kind of print needle tip, from a 14 gauge needle tip. And if you wanted to reduce to a 22 gauge needle tip, basically reducing the resolution what are the parameters that you need to change on Slicer to allow you to achieve that print. So that's the first thing that we'll do. The second one is when, let's say, you're adjusting the material viscosity. So in this case, we'll demonstrate how we would adjust the material viscosity and also, I guess, adjust the print parameters from a 40% to 35%. So obviously 35% pluronic is gonna be less viscous. And again, we'll go in step by step to show you how you would need to adjust the print parameters in order to achieve a consistent print when you reduce the low viscosity to a lower viscosity. And then finally, if you're looking at printing very fine resolutions, for example, going down to like the 100 micron ranges, there are certain things that you also need to take note of, mainly particularly the speed. So in today's demonstration, Oliver will show you how speed will make a big difference. So with that, I'm gonna switch over to a different to the Slicer program software. And this is where you can now actually follow us and open the Slicer program. And you can basically step by step, you could follow Oliver through this step. So I'm gonna hand this over to Oliver. Let's see. Yeah.
Okay. Hey guys, thanks for joining us. So first, let me share my Slicer screen. And so for our first activity, we'll be switching from a 20 to a 22 gauge needle from a 14 gauge needle. So the first thing I'm gonna do is just load a config that I've already made for the 14 gauge needle. And then the first setting I'm gonna change is to do the nozzle diameter. So here I have 1.6 millimeters, which is the nozzle diameter that matches the 14 gauge needle inner diameter. And I'm just gonna change that to match the inner diameter for the 22 gauge needle, which in this case is 0.413. And then the next setting that I wanna change is in print settings. I'm going to change the layer height and the first layer height. So these two settings can only be as high as your nozzle diameter, which makes sense. In this case, we're just going to set it to almost the same, or 0.41 for both. And then now I can add whatever file I want. Oh, can you send me the cube? Okay, so now I'll add the cube again. And then now in my preview, I can see my scaffold shape. So all I'll do is export this G code. And then now I can print on the printer.
So Oliver is going to basically load the scaffold, the G-code file that he just outputted onto Pronaface. And now he's basically going to load the syringe. So here in this, we have pluronic material, which is in green. And we're using now the 22 needle gauge. And we have a print that we did on the 14, which we'll show you later on as a comparison as well to see what the difference it looks like. So before you begin a print, you typically want to kind of calibrate the Z0 position. So we do this by just sliding a piece of paper underneath it to make sure that the Z0 is basically a paper thin distance before you start printing. If we're able to see that. Can you see it? Yeah, it's hard to see because of the. Okay, I think as the printer starts printing a scaffold, you might be able to see the scaffold a little bit better because I think the white balance is not really showing the scaffold very well. So we'll print about 2 layers of this, and then we'll kind of show you a comparison between the 14 gauge needle tip and then this is the 22. And you'll see a very drastic contrast of difference between the 2 scaffold prints. Mm-hmm. So we'll just bring this closer to you so you could see maybe take the tape off, yeah. You could see the scaffold resolution is pretty fine. This is the 22 gauge needle. And then here I'm gonna show you sort of a side-by-side. This was something that we previously printed, which is the 14 gauge. And you can see this scaffold has, you know, much greater kind of thickness layer, both on the perimeter and also on the inside as well. So the next one I think Oliver is going to do is to adjust kind of the viscosity of the material. So we'll go back into Slicer and he'll show you what are some of the settings you need to change if you want to change the viscosity of the material. This one will be harder to see, but we want to kind of walk you through the different settings.
Okay. So I already have my 22 gauge config file, which I'm going to keep for the most part. But the main parameter that I want to be tuning is over in the filament settings. I want to change the extrusion multiplier. So the extrusion multiplier is just a number that kind of linearly varies the amount of material being extruded. So if you're used to using a pressure-driven bioprinter, then this would be analogous to the pressure. But ours is a positive displacement machine, so this will just push more material out of the syringe for every movement that the bioprinter makes. And for a less viscous material, you can decrease this number by a little bit. For more viscous materials, then I would want to increase this number to kind of push more material out of the syringe. So in this case, for the 35% viscosity pleronic, we can change this to approximately 0.1. And then I already have my model from before, so I can just export this G-code and save it, and then we can print again.
So let me stop this. So we're going to go back to the printer, and as I mentioned, in this print, it's harder to see, but you know, when you have something that is slightly lower viscosity, it tends to be a little bit runnier, right, than the previous kind of material that we were using. So it does, I guess Oliver will show maybe 2 prints with a wrong setting and the correct settings. Oh, this is, was this with
this is with the too low extrusion multiplier.
I see. So I think previously Oliver did a print that has too low of a extrusion multiplier, and you can see here the scaffold is inconsistent. The prints are very inconsistent. And so you do need to adjust the extrusion multiplier to the right setting in order to get the right kind of amount of material coming out. So he's going to show you with the adjusted parameters what the print will look like. So typically we try to print like a skirt before we actually print the scaffold, just to ensure that there's flow coming out before you actually run the print. I don't think this is actually coming out at all, Oliver. There's no material coming out. Is this a resonance? It's not coming out. Are you sure? No, it's not coming out. Is it too close to the dish, maybe? That's why it's not printing. I think it's too close to the dish. Maybe 2 layers, isn't that? So there's a question about the scaffold material. So this material that we're using is actually a synthetic hydrogel called Pluronic. So we'll just show you quickly how this print looks like. So you can see this is how the print looks like. You can see the I guess the scaffold design is still pretty consistent. So because we've already adjusted it to the right sort of parameters. And previously this was the green one, which was the 40% Pluronic, right? So you can see it looks very similar because we're using the same needle tip. But it's hard to see the difference in the viscosity because it's essentially the same material, but the 35% is definitely a little bit sort of runnier compared to the 40%, right? So that's sort of the second setting that we wanted to show you guys when you adjust kind of material viscosity, what do you need to change? And the final one we're gonna do is when you print something at really, really low, I guess, low diameter or really high resolution, so to speak, right? So when you're printing in the 100 micron ranges, then the speed actually becomes a really important parameter. So Oliver will demonstrate a couple prints that perhaps show, you know, with the right speed, you can actually get really good prints.
Okay, so we're gonna go back to Slicer and we'll be printing with a 30 gauge needle for this one and a 30 gauge needle for the nozzle diameter. I'll change that to be 0.16 or 160 microns. Then I'll go to my print settings and change my layer height to be just under that at 0.15. And then for these prints where the needle diameter is really small, I also want to decrease my speed. So here we were printing at 10 millimeters per second, and then a safe speed for the 30 gauge needle is around 5 millimeters per second. So I'll just change all of these ones to 5. And then the travel I can keep at 50 millimeters per second because that's when the printer is just moving and not actually printing. And then I also want to make sure that I add a skirt. So I'll just change this value to 1 to have 1 loop around the model, which you can see here. And then I'll export this as a G code. So.
Okay, right. All right, so now we'll go back to Pronoface, and Oliver is going to prep the printer to print with the 30 gauge needle tip this time. No, there is another question. Wait, let me stop this share here. There is a question about printing pluronic on top of another material, like maybe a metal or a glass, instead of printing on a petri dish. Yes, you can print on any flat surface, essentially. You could print on metal or glass. Pluronic is a thermo-reversible material, so when it's actually in a cold temperature, like 4 degrees Celsius, it actually becomes a liquid, right? But if you bring it up to room temperature, then it becomes a gel-like material, which is what you see here. And it's a very printable gel material. So it's great for printing scaffolds and especially channels where you could actually dissolve the material away if you have it embedded in another gel or PDMS and whatnot. So it's a bit hard for you guys to see, but here we have a 30 gauge needle, which is fairly thin. It's probably as thin as you can get with these disposable type needle tips. And Oliver will show you, I guess, the good print first.
Yeah. So I have a slow version that I just made, and then also a fast version where you'll see that the speed really does make a difference.
Yes, so there's also a question about the paper test. So we typically slide a piece of paper underneath it before we begin a print. That is sort of using the paper as, you know, a way to sort of set the Z0 position. So you want to start a Z0 position, which is sort of paper thin. So it's kind of the traditional 3D printing, you know, method of zeroing the Z height. We also had a question about if you could print on a surface that's not flat. So that's a little bit more challenging if, you know, unless you know exactly what the dimensions of that surface is. I think technically, I guess it is possible for you to print over a mold or something, but you have to know the specific dimensions and basically design it into that scaffold thing that you would be creating. So it is possible, but just a little bit more challenging. And we also have another question about you want to coat the design with pluronic. Can this be done, or is calibration required? Yeah, so I guess if you're trying to coat something with the surface, I think it depends on what that design or the scaffold is to begin with. So it is possible to quote unquote coat with pluronic. I think depending on the design, right? If it's a very simple design, you could basically, you know, use pluronic to kind of create patterns on it. But if it's something that is a little bit more sort of challenging, then what I might recommend is maybe just coat it with collagen, like something that is a bit more liquidy that you would just pour over and let it kind of just, you know, coat the surface as it is. So you will just basically gently pour the liquid over it rather than creating shapes over the system. So fresh. So there is a question about fresh. And yes, so fresh printing is a bit different because the idea of fresh is that you're actually printing in a slurry of gelatin, right? And the slurry basically serves as almost a support material. And it's great for printing things like collagen because collagen has very low sort of viscosity. And if you print collagen on its own without any support material, it's not going to hold its structure very well at all. So the idea of fresh is that you could actually, you know, use the slurry as a support material and be able to print some really intricate structures using this soft material such as collagen. And actually on that note, we will actually show one of this fresh printing in our next webinar. So I will definitely encourage you guys to continue joining us. And pluronic is different from collagen. So pluronic is a synthetic biomaterial. So we have it in our slides, and those of you who missed it earlier, you could definitely reference back to the earlier webinars. You know, we'll share the video, the recorded video after at the end. So there's a question about the viscosity of pluronic and also how much pressure we're applying. So we haven't actually measured the exact viscosity of our 40% kind of pluronic material. But, you know, I think my guess in terms of the material, it's the viscosity of pluronic is very similar to other hydrogel-based materials. So I would think it's sort of in the range of about maybe 100 centipoise or so. And in terms of pressure, again, you know, it's not something that I think the pressure has to do with the needle size, right? So depending on whether you're using a smaller needle size or a larger needle size, then the pressure will be different. And again, we don't have any system right now to measure the exact pressure. So I just want to show you quickly the final print that Oliver has created here. I can't see my own video, but I hope that you can see. So you can see that it's a lot, sorry, is that better? Yeah, is this better? Okay. So you can see on this scaffold, the resolution is a lot finer than the previous ones, right? But you can see that with the right speed, we could get a pretty consistent and almost homogeneous kind of pattern across the entire scaffold, right? So this is the good print. And I think Oliver is going to show you a bad print. If you don't have the right speed, then you won't get such a homogeneous print throughout the scaffold. So we'll show you what a faster, how, you know, by just changing the speed, the print is going to be a little bit more, quite different. So just to clarify, there was a question about the different materials that we're using. So today we're actually only using a pluronic material, and so far we've only, you know, adjusted the viscosity to, like, one of the activities we did was lowering the viscosity, but everything else was just on the standard kind of pluronic concentration that we typically use for printing out scaffolds. So we haven't really played with other materials, at least not in this webinar. We're not showcasing different materials. So you can see on this print, the printer is going faster. I don't know if you guys have been watching closely, but you can see this one is going a little bit faster and it's vibrating a little bit because it's going so fast. But I think once we see the final print, you'll see how the speed does make a difference when you go to these really fine resolution. Okay. Okay, so Oliver will show you. This one is the one with a faster.
Yeah.
Is
and
it
then
easy?
you can see how over here the perimeter hasn't exactly printed properly. And also you can see the skirt, it's kind of skipping and beating up because it hasn't really contacted the petri dish well.
Yeah, so I think as Oliver highlighted, that previous one was, you know, you can see I guess the print scaffold was a lot more uneven, and then this is the one that has the better kind of printing conditions, right? So it's a lot more even. Okay, so that sort of ends the three kind of parameters that we wanted to showcase to everyone. And let me just go back to the slides. I have a couple more slides, and if you have more questions, feel free to shoot away, and you know, we could open it up later for Q&A, and you guys could turn off your mics if you wanted to raise the questions as well. So let me go back to, I just wanted to share with everyone before we end today's session some of the other activities that we have lined up for the next couple of months. So upcoming workshops and webinars. So we try to host these workshops, I guess, webinars at least once a week, once a month. And we also try to host workshops in Santa Clara. And if you're in the area, you know, you're more than welcome to join our hands-on workshops, so you could get more close-up one-on-one. So the next one coming up, we're actually hosting a hands-on workshop in bioprinting at the 3D Heals conference. So my good friend, Dr. Jenny Chen, is the host and CEO of 3D Heals. And this is really one of the, you know, largest healthcare 3D printing and bioprinting conference in the world. And I highly encourage those of you who are interested to participate in the conference. And on Friday, we will be there'll be a series of different workshops, and bioprinting is just one of them. So if you're interested, please check out the website 3dheals2018.com. And Saturday, 21st of April is the actual conference itself, where you find many different speakers from dental 3D printing to medical 3D printing, and of course bioprinting, and so on and so forth. And the next webinar we're going to host is going to be on custom models. So using more sophisticated 3D printing 3D CAD design tools such as SolidWorks or maybe Fusion 360 to create some really customized models that, you know, that you could really specify to, you know, with different curves, curvatures and whatnot. So that will be the next webinar. And as I mentioned, we would also be demonstrating printing with collagen, which is the fresh printing method. For those of you who are interested, and we'll definitely share some tips and techniques on using the fresh printing method. And last but not least, I'm sure some of you might be curious, how much is the Rebel Mini? And if you wanted to get your hands for one of these, and you know, if in the future when we're doing these demonstrations, you could kind of run it alongside. The Rebel Mini is going to be priced at $2,400, and we actually sold out all of our beta versions in the first month we launched it. So we literally have nothing else, nothing more to offer today. But if you're interested to get one, which will be available as soon as in May, please pre-order. So you could go to our website and pre-order the Rebel Mini, put your name down. And then also, of course, if you want to purchase Pluronic, and if you do have your own bioprinter already, you could purchase this ready-to-use Pluronic material from us as well. So you could also go to our website for that. And with that, I think that's it. You could definitely email us if you have further questions at info@se3d.com. We're also pretty active on Facebook, Twitter, Instagram, and LinkedIn, of course. Most of you found us through LinkedIn about this webinar. So definitely welcome your feedback and any questions you might have. So, so I will stop this screen. Yep, so there is a question from one of the incubating the material. Okay, so as far as incubating this material, you could incubate pluronic and in the incubator. I think the issue with pluronic as sort of a scaffold for seeding cells is the fact that the moment you add media to pluronic, it actually dissolves pretty quickly into the media, which is why, as I mentioned, pluronic is typically used as a sacrificial material more than a scaffold material for supporting cell growth. But yeah, you could incubate the material. I think there was a group who actually printed pluronic with bacteria and kind of incubated that for a day or two, and bacteria was able to grow in the material, so it is possible. And I think the next question was, what if we have a design that is made of 2 different materials, including pluronic? Is it possible to incubate the 2 different materials in the same condition? Yes, so I think without knowing too much details of what the 2 materials are, but technically, yes, you can print, different materials and culture them depending on what cells that you're using 2 different materials in a petri dish with the scaffold. So yeah, so I would say generally that is definitely possible. Any other questions that the other audiences might have? And you can unmute yourself if you wanted to just raise the question to everyone. No other questions? All right, so if there are no other questions, I will be sending you a couple of emails following this. If you're interested to get a link to the recording, let me know, and we will be able to share that link with you so that you could kind of review the step-by-step protocols that we provide. And we'll also really appreciate any feedback. So I'll be sending out a quick survey. Will take you like 5 minutes to complete the survey. Just give us some feedback about what you think about these webinars. And of course, if there are other topics that may interest you, we'll be more than happy to do that for the next session as well. So thank you everyone. And I hope that you've enjoyed this session, and we'll see you hopefully in the next webinar, or if not, we'll see you at 3D Heals. Bye.